Hello, everyone. I want to take us through an example that explores an exponential experience that's a little bit more realistic to us. So, Sierpinski triangle and Koch curve are definitely things that exist and things that mathematicians explore, but something that you will definitely experience in your lifetime is the idea of interest, whether that's positive or negative for you. Most people have both experiences. So I want to take a look at how we can take what we learned with the expanded form, with the exponential form of situations and being able to depict them. So I want to take something simple like savings account accruing interest. So we have this person, Seth. Actually, I'm going to change that. Let's say Mr. Garlitz is the one here gaining money. Let's say that I deposit $200 in a savings account and that I get 5% annual interest. We haven't talked about percents in quite some time, so we're going to have to do a little bit of review or maybe make sure that we know what that means. But annual interest. So annual meaning yearly. So let's get some of that out there. In math lingo, 5% has several representations. I'm going to refresh you a little bit. So 5% is the same as 5 out of 100, which we recognize is the same as 0.05. Okay, so those are things that are going to be really important. We're going to stick with the decimal version of it. So whenever you see 0.05, you should know that that means percent. And then annual, meaning yearly. So every year this happens. Assuming that I make no more deposits and no withdrawals, meaning I don't put any more money in, I don't take any more money out. This specific example is saying how much could I get back after 10 years? So let's start off with kind of organizing this experience. And I want us to take a look at the two forms that we've looked at so far, which is expanded and exponential. So we have a starting balance, which is $200, right? $200. And then I'm going to write this in expanded form, exponential form, and then a new balance. So for us, $200 is just written. It's expanded, it's exponential, and so our new balance at when we start is just $200 because nothing's happened. So this money has sat in this account for a year, for 1 year. So after 1 year, and the question is, how much does it gain? So when we look at that, before we continue our table, $200 is going to undergo, and it's going to go 100%, and then we're gaining 5% after 1 year. And so to write this in its expanded form, we're going to write it like this: 200 times 1 plus 0.05%. I might run out of space with this. The exponential, we're multiplying it one time. So it's only after 1 year. So 200, 1 plus 0.05 to the first power. I'm definitely going to run out of space here. Let's do this. Let's take a shift and move this to a Desmos table. All right, so starting balance. Let's turn this off for a moment. And And then actually, this is after 0 years, right? We haven't had anything happen. So our starting balance is $200. Our expanded form is, let's call this expanded. It doesn't look like it does it. Let's call this y2. And then what I'm going to do is I'll just make a note so that we know what that means. So y2 is expanded. And let's say y3 is exponential form. All right, so I'm going to make sure I put in a y3. Close these up, and then I'm going to put in a y4, and we'll call y4 our new balance. All right, so $200 becomes $200. Nothing happens there. So then after a year, we're going to have $200 plus 5% of that. 5% times 200. So that means that our new balance is $210. Okay, now the thing here to think about is that when we write something like this is the same as writing it in expanded form. 1 plus 0.05 and exponential form. 1 plus. Right now it doesn't to the first power. Right now that might not make as much sense to us because we don't have a whole lot happening. But if we take our second year, now we're multiplying it by 5% twice. So I'm taking what I gained. So I start with $200. This is from my first year, like a recursive routine, and then I'm multiplying it by 1 plus 0.05 again. Let me expand this table. It's too bad. I'll make sure I write that out. But then, since we're doing it twice, so 1, 2, I can consolidate that in exponential form by putting my power to the second. 1 plus 0.05 to the second power. Okay, so let's figure out what that is. $220.50. And we're going to continue this pattern all the way down. So I've got all of this, and then I'm multiplying it by another year has passed, year 3. So yay, we gain more money, 5% more, because I haven't put any money in or taken any money out. And then this time, I'm going to the third power because I have 3 years. So let's see what that gives us. 3 years, $230, and we'll round to 53 cents. Okay, so this is getting kind of tedious, right? So let's look and see if we have a pattern yet that compares our X value, our input, the number of years that have passed, to the amount of money that we gain or some value in here. Well, if you look, I've got 1 here. I've got 1 here. 2 here. 2 goes in my exponent. 3 here. 3 goes in my exponent. So in this case, it's really beneficial for us to put this in exponential form because it makes our life easier. So I can do how much money I'm going to make after 10 years on this interest rate just by putting that value into the exponent here. Whereas an expanded form, even though it's really useful, I would have to write that out 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a lot. So it looks like $325 and we'll say 78 cents. And then this whole expanded thing goes right in there. So the question is, do these all match up in our graph? So let's turn these on. And this really should be 200 and 200 times 1 plus 0.5 to the 0, right? If we're matching our pattern. So let's make sure that that lines up. Let's hide these. All right, so we're going from 0 to 10 years, and it looks like we're starting at 200. So I'm going to make my y value. We'll start at 0 here, and then we're going to go up to, let's say, 500. Okay, so we've got this relationship here, year 1, year 2, 3, 4, and then we did 10, right? So let's take a look and see. I'm going to push these all kind of close together. Let's turn off our total. Okay, we see our purple, so that's our exponential form that goes underneath. We see our green, great. So that is our expanded form, and then we're going to see blue, which is our starting value right there. So what I always want to push you to is, well, what if 10 is x? What if we don't know how many years and we just want to make a prediction? This is an exponential relationship, right? We have an exponential, so we can write an exponential function based on that. So let's say f of x function is starting value 200, constant multiplier is 1 plus 0.05. We could consolidate that to 1.05, and that's going to be to the x power. And this is a good curve for us for people that are putting money into a bank because it's going up, right? As time goes on, our money increases. And let's just make sure that all of our points fall on that line so that we know that we did our calculations correctly. All right. Green are on. So that's expanded form, exponential form, and then the totals. So if I ever wanted to figure out, let's say I put that money into my bank when I was younger, and let's say I did it when I was 20, and I want to know what's going to happen when I'm 70. Well, I can go and I can say 50 years later, how much money am I going to have? So by putting $200 at 5% interest for 50 years, I'm going to gain almost $2,100 just by letting it sit. So this is an example of simple interest in looking at exponential functions.